Hello and welcome back to the channel. In this video I have this old dusty battery charger and I had to use it for the first time in years the other day, and I want to do a couple upgrades to it. For one thing, I don't like how as soon as you plug it in the terminals have 12 volts on them, or 6 volts I guess if you have it on that. So you have to be very careful that the two ends aren't touching. So I'd like to have it, put a switch on it so you manually turn it on when you want it to actually be putting out voltage. And the other thing is, it has this little amp meter on it, but there's no voltmeter. And I happen to have a little $1 voltmeter kicking around that I've had for a long time, and it's good up to 30 volts, and this thing doesn't go that high, so it worked out perfect. Because when I had to use it, I'd have to unplug it, and that way I could hook a multimeter up to the battery to see what the voltage on the battery was. And those two little things will solve that problem. I just turn the switch off and keep it plugged up, and then I'll be able to check the voltage without having to get my multimeter out. So I've already took the top off of it, and it's very simple. It's just a transformer and I'm assuming a full bridge rectifier, and the switch, which is 6 volts 6 amps, 12 volts 2 amps, 12 volts 6 amps. So I'm thinking put the switch on the back and put the voltmeter on the front. We'll see how it goes. I have a pack of switches that are rated for 6 amps at 125 volts, and I would rather just switch the output instead of the input. So this is a 6 amp charger. If it can handle 6 amps at 125 volts, then surely it can handle 6 amps at 12 volts or 14.4 or whatever. And here's the little $1 30 volt voltmeter. There are different models apparently, 30, 200, 100, 500, but I bought a pack of 10 of these. If I'm not mistaken, they were $1 a piece, and the 10 pack, or might have even been more of these, were just $1 or so. They're very cheap. The third and final modification is, well, when I was using it the other day, we were actually running a small pump, pumping some kerosene, and well, it was charging the battery and pumping the kerosene at the same time, and I noticed the charger was getting awful hot. It might actually kind of tripped some kind of thermal breaker at one point. I unplugged it and plugged it back, and it seemed to be good, or maybe it was something else, I'm not sure. But so out of all my fans, I got a box full of just old fans from computers and such. I found one that was rated for 24 volts. All the rest of them were 12 volts or even 9. So because the battery charger goes above 12 volts, I wouldn't want to use a 12 volt fan. And because since it's a battery and it has voltage of its own, when I cut the power off, the battery could be running this. So I just took 2 diodes. I mean, I'm not an electrical engineer. Maybe one diode would have done it, but I put one on each leg, in the proper order. I think they're 1N4007, if I'm not mistaken. But these diodes will do the job. So it definitely won't be running at 24 volts. More like, up to 14 and as low as, I guess, 6 volts. I'm thinking about having the fan blow kind of between the transformer and the rectifier, because I'm not sure what exactly was getting hot. I just kind of had my hand on top of the whole case and noticed heat coming out. It has plenty of cutouts on the bottom and cutouts on the top for airflow, but having a fan in it won't hurt anything, especially being it's like 0.07 amp fan. It's not going to take away from the charging really. So I put some small heat shrink on the diodes, the soldered part. I just have the leg sticking out for right now. But as far as the fan placement, there's holes on the bottom right here, And you know, having it right here will cover the transformer and the bridge rectifier, so I'm thinking just right there would be a good spot. So the plan is just to put a bead of hot glue right here just to kind of hold it steady, and I'll mix up some epoxy and give it a good 24 hours to bond good, because I don't know about using hot glue in general, because since it gets hot, you know, maybe it's hot enough to melt the glue, so it wouldn't be very permanent using hot glue. So I got the hot glue gun heating up right now. That's going to be my next step. And it seems, I'll have to verify it, but I think the positive output's right here and the negative output goes to this little amp meter. So I just tack one leg here and one there. I'll have to add some wire, of course. So yeah, the fan will go there. I'll probably have the switch on the back, probably. I haven't decided yet. And a little voltmeter right here. So it should be some easy modifications. Well, it's been a few days later now, and I ran into a few problems. Well, let me draw it out here. Like, here's the transformer. It had 3 taps, because it was a center tap. The end 2 went to some kind of block, and had an output that went to one of the clips, you know, that hook onto the battery. And the center tap, that's the one that goes over here to this amp meter. So it goes to the little amp meter thing, and then it goes right to the negative terminal. So I'm not exact. I was thinking that this had to have some kind of diode in it or something, but apparently it doesn't, because long story short, ended up frying my little $1 module here that was supposed to be rated for 30 volts. So makes me think there's AC on it, but I mean, it works fine with charging batteries, and that's how it was from the factory, so I didn't want to fool with that, really. And since this was only $1, then oh well. But because of that, I kind of scrapped the idea of having the voltage output, and I already had the hole cut out for it, so I ended up just sticking a switch in it, which had a little bit of a gap, so I just kind of filled that in. And also, the other problem is the fan I had mounted. I had the fan in there, and I had it epoxied in and everything, and I'm guessing the fan was just so old and crusty, I kind of put a little pressure on it, and it cracked, so I ended up taking that out. And with my mods to it, I ran out of room, so I put the fan externally. It's just a 12-volt fan now. The little buck converter on it is just so no matter what selection of voltage I have it on, it stays. I have it set to 11 volts. Just to give it, you know, a little bit of play in case I hook it up somewhere else with a little bit higher line voltage. I didn't want it to be over 12, so got the fan running at 11 max. If you got it down some, you know, to the 6-volt setting, it's not going to be that high. But so pretty much what I've done is I just took, you know, here's tap 1, tap 2, tap 3. I added 2 bridge rectifiers, so one goes from the 2 external taps. And I added some banana jacks to the back of it for that. And from the center tap onto one of the taps is right here on the front. So let me turn this on. So I didn't interfere with the charging at all. I just kind of, if I'm not using it for charging a battery, then, you know, it'll have other uses, which is generally most of the time I'm not using it to charge a battery. So now it has a power switch, which is one of the things I wanted. Another good thing about this little module is it has a LED on it, so that kind of double confirms that you got it powered on. So at the lowest voltage setting with the switch that was already on it by default, getting 10.7. Switch it to the middle, 13.6, and this 12 volt 6 amp setting, 17.6. And you may be thinking, you know, that's not very useful voltages for everyday things, but the plan is, you know, I just hook up an external buck converter, you know, kind of like this one here, and, you know, I can adjust it, fine tune it with the little potentiometer to the exact voltage I want. And put it back on the lowest setting. And it also changes the speed of the fan, which is nice, so under, you know, higher voltages, the fan goes higher. The back terminal here will definitely be used less often. But the lowest setting, well, its capacitor is probably still charged. It's showing 40 volts, which is usually what it is on the maximum setting. I wonder if I set it to ohms, if it'll discharge it a lot. Alright, 25 volts on the lowest setting. Then it jumps to 33 on the middle setting. And generally about 40 on the highest settings. So, you know, that gives me a lot of useful voltages, anywhere from 10 volts to 40 volts pretty much. And everything else is still factory. You know, this still gonna charge a battery, which I have a little slab here, sealed lead acid battery. And yeah, now I have my power switch like I wanted. And everything else is still factory. It just has more use than it once did, and it has better cooling than originally did for sure. So, guess that about ends this video. The only thing really that I had planned to do is when I was taking off the little plastic, it was really thin, brittle plastic faceplate. It kind of just came apart. So I made somewhat of an outline before I added the banana jacks and the plug here. And I might use some, put this on some cardboard, add the holes that I need, and write, you know, what each thing is. Or I have a label printer, maybe just print little labels for each thing. But that's about it. Thank you for watching.